I'll mention more. All right, so.
Okay, so the last speaker
is this on?
Randall.
Yes, thank you. Thank you. So I guess I should start off with a couple disclaimers. So this is not a technical talk. If you want a technical talk, you can go to the other room. You have a few minutes, so I won't feel bad. When Matthew asked me to come, I looked at the program. I said, I don't do anything. I'm not that has to do with electronic materials. I'm pretty far removed from this, but he encouraged me to come anyway and said it would be good if I came and gave a perspective on EE at Northwestern to help establish more collaboration. So that's the purpose of this talk. It's just a talk, give you an overview of what's going on with electrical engineering and more broadly with electrical engineering and computer science at Northwestern. But I will, being an academic and having the stage, I have to say at least a couple things about my own interests. So briefly, I'm on to the other side of EE, if you will. I work in communications. Wireless communications is my background, so I'm interested in things like wireless scheduling and interference management. I've been doing a lot of work on wireless spectrum sharing, some work on information theory and combining information theory with game theory recently. I see at least one information theorist in the room. And a little bit of network economics as well, so problems that have to do with combining economics with agents and networks and their incentives. So I'm not going to talk about any of that today. If you're interested in any of it, I'd be glad to talk later. So I said I'm here talking mainly about EE. So at Northwestern, things are structured a bit differently. We have a single department of electrical engineering and computer science. It's a department of about 50-some faculty. It's the largest department in the engineering school and probably one of the largest ones at Northwestern. And in that department, we're divided into 3 divisions. So we have a division of electrical engineering, a division of computer engineering, which Seda was in, who you just heard from, and a division of computer science. And then within electrical engineering, we have 2 main, what we call research interest groups. So we have one research interest group that's solid state and photonics, and one that is what we call signals and systems. So this is where the stuff that I do lives, over in signals and systems. Things like communication, control, signal processing. Solid state and photonics is mainly where the topics that we've been hearing about in this workshop on the EE side live at Northwestern. Okay. So here's a picture. I told you we had about 50 faculty. I think that's most of them up there. This was from a advisory board presentation last year, so some of the newer faculty aren't there. And we have some adjunct, courtesy, and emeritus faculty. And one of our adjunct faculty is Bruce Wessels. Courtesy faculty, not adjunct, right? Courtesy faculty is Bruce is here. Also lots of staff, given a department of this size. And so I'm mainly going to focus on the EE division because I assume it's sort of the closest to what most of the people here are interested in. So as I said, the EE division, you can divide it into these 2 different research areas. We have faculty that are doing things in solid state and photonics, which are in the purple rectangle over here, and faculty in signals and systems, which are on this side. And it's a surprise, it's actually nicely balanced between the 2 sides. At this workshop, so Corey and Matt are here, and Salim is here. So we have 3 out of 10 faculty. So there's 7 more people that are doing things that would be of interest that didn't show up here. We have Sang Ho, who does things on nanophotonics up here. We have Prem Kumar, who is interested in optical communications and networks. And Prem's currently on leave, where he's a program manager at DARPA. Here we have Cheng Lu, who is joint with EE and mechanical engineering. And he does things related to bio-inspired sensors and nanofabrication. We have Human Wassini here, who does work on single photon detectors, among other things. We have Manija Rajegi here, who does work on compound semiconductor science, nanotechnology, lasers. Alan Tafloff, who does a lot of work on computational electromagnetics. In fact, he's the father of the FTTD method. And finally, we have Horace Ewan down here, who is a theoretician who does things related to quantum optics. Okay, so those were, I just mentioned the people that weren't here. I won't go through everyone on this side, but we have people here in communication, signal processing, control, video processing, biomedical processing, and smart grid. Okay. So additionally, in EECS, there are 5 different centers that are affiliated with the department, meaning that the people that are running the centers are in the department. So there's other centers at Northwestern that we also have connections with. The 2 that are probably the closest here are the Center for Photonic Communication and Computing, which is ran by Prem Kumar, and the Center for Quantum Devices, which is ran by Professor Ozegi. Right. And then also over here, the Center for Ultrascale Computing and Information Security, I think SATA is affiliated with, so they do a lot of things like you've just heard her talking about. I'll get to that. I'll get to that. Okay, good question. All right, so these are basically the research areas that we cover in these two different parts of the department. I don't know if there's a need to go through all of these. I've sort of alluded to them already. EE is I think, a very vast and wide area. So we're a relatively small department by EE standards, and there are some things that are missing here, but I think we've covered a lot of the main areas in EE. All right, so I can get to your question, enrollments. So this is showing our undergrad and graduate enrollments from last year, from last academic year, because those were the only numbers I had. So what's on this side is our undergrad majors. We have 67 in EE last year total, so this is all 4 years. They had 83 in computer engineering. And in computer science, we have actually 2 computer science degrees. The largest one is through McCormick, the engineering school, which is at 164. This has been growing like crazy over the last 5 or 6 years. So I think if you went back 5 years, this would have been comparable with these 2. And we also offer a computer science degree in Weinberg, which is the humanities college at Northwestern. Okay, it's a smaller degree there. They all take the same major coursework, but they take different electives of different outside of major courses if they're in Weinberg. Okay. Over here is our graduate student population. So I didn't have this data broken down by major, but across the whole department, there were 160 PhD students, 154 master's students. Many of these are terminal master's students, so they get a master's degree and they go to work or go somewhere else. And we also have a joint BS-MS option. So our undergrads, while they're getting their bachelor's degree, can go straight through and graduate in 5 years with both a bachelor's and a master's. And about 37 students are doing that. Okay. So feel free to stop me if you have questions.
MS students, are those all self-paying students?
A majority of them are, yes, yes. And that's also been something that's grown a lot over the last few years.
And the BS-MS are?
Are, of course, yes. Yes, so most of these are self-paying. These are, of course, not.
Regarding the undergraduate, is it limited by the demand of the students or by your acceptance criteria?
Good question. So it's the number that is admitted into the college each year, the engineering college, is limited, so to around 400, I believe. And of those, they're admitted into the college, not into individual departments. So then they select. Okay, so it's a bit of both, a bit of both. All right, any other questions before I go on? So just a couple of comments. I think we're a department that have collaborations both within the engineering school with lots of other departments. I just listed a few of the ones here that I think are some of the more prominent. We have connections with mechanical engineering, mainly in the robotics area. We have connections with biomedical engineering, so people who do, say, signal processing. Our current chair actually has a joint appointment with BME. We have connections with material science, with people like Bruce here. We have some connections with industrial engineering and management science. So one of our new hires who does optimization for networks, that's also a big topic in industrial engineering. So we have some connections there. And then we have some connections with civil and environmental engineering. So again, doing things like monitoring bridges using sensor networks have nice connections, or traffic management as well. Okay. So that's within the engineering school. There's also lots of connections across the university. So Northwestern, like I was hearing Tel Aviv is a university that has lots and lots of different departments and schools, ranging from a school of music. We have a School of Medicine, Feinberg, a School of Communications, a School of Education, a School of, I said, the Liberal Arts and Sciences. So this is the physics department mainly, our connections here. Kellogg is a management school, business school. We have some faculty that have joint appointments there. And Medill is a school of, what is it? Journalism. I was going to say communication. I knew that was wrong. Okay, journalism, right. So lots of ties. These are just faculty that have joint appointments. And then, of course, in addition to this, there's other collaborative efforts that are going on that aren't sort of shown here. Okay. And also lots of collaborations with different industries. And I'll just throw up this slide. This was another one from our advisory board meeting showing lots. So I think all of these represent either grants or gifts from different companies.
Well, I'm just curious.
Mm-hmm.
I have an interaction with the field music.
Yes.
What is your interaction with the field music? I'm just curious.
That one I don't know. That might be through, so that's, as far as I know, that's not an EE. That might be through CS.
Oh, the field music, no.
Do you know? I know there's some with the Art Institute.
But it's about Art Institute.
Yeah. I know the Art Institute or some with signal processing where they've been doing these, imaging and
There are people in material science also.
doing that. Right.
There's a formal
Yes.
interaction.
Right. So I don't know is my honest answer where that one came from. All right. Okay, so this, I don't want to spend a lot of time on this. Is basically the mission statement of the department. But I think one of the things I put this here was to highlight, the global reach and impact is something that we as a department care about, and so that's where having a dialogue with other universities like Tel Aviv make a lot of sense to us and are well aligned. And in fact, we've been doing this. So Matt Grayson, who's here, is the Director of International Programs and Relations for our department, and he's also the co-director for Global McCormick, which is a engineering school-wide effort at establishing better international programs. And one of the things that they've been doing, and I'll say a little bit more about this, is working with universities, including Tel Aviv, Koch University in Turkey, and ETH in Zurich, to try to establish a Rosetta Stone, if you will, curriculum list that makes it very easy for our students to apply for study abroad. So in the past, if a student wanted to do study abroad, basically they had to go and chase down people to get all the courses approved every single time they did that. And it was a painful process, and they're trying to make this much easier on the students and increase the number of students that are doing study abroad, and also making them aware of the opportunities that are there. So a lot of students just didn't know these options were there. Mm-hmm. Can I say? So yes, that is a good issue. So we are on a quarter system. So we are in 3 quarters. Unfortunately, which makes these things an issue. The fall is the better one, I think, for doing things when we're sending students or getting students from a place that's on semesters. Because the fall quarter starts late September and goes through December, so the students can come and start early. Matt can say more if you.
When does your fall semester end?
Mm-hmm.
In the middle of January. Is that classes and lectures or just exams? No, lectures. Lectures end in the middle of January.
Wow, that is a.
And then when does the? Then 6 weeks exams. Now we have 6 weeks exam from mid-January to beginning of March. And then the March. Then the second semester starts.
Ah.
On which date? Beginning of March. March 8th.
So that might.
By a week from year to year.
This year is March 8th.
Mm-hmm.
We are following the Hebrew calendar.
That might actually work better with spring than
Yeah,
with the spring. Mm-hmm. So our spring quarter starts around.
One of the we can talk in detail
Yeah.
later, but one of the things that we did, so we've got a situation where we don't have a clean overlap with only our fall quarter, only our winter quarter, only our spring quarter. One of the things that we're working out with Shanghai Jiao Tong University in China, they're putting together sort of a 1-month cultural program at the front end, or a language program or something that's affiliated with the university, so that students can come over here, get acclimated, get oriented, and earn academic credit, and then feed into the start of, say, March 8th or something like this. So that instead of, because if a Northwestern student is giving up the winter quarter and the spring quarter, where they're earning basically, they're earning, I guess 4 or 5 months worth of credits, or they're losing 4 or 5 months worth of credits, but they're only getting back a little bit less than that. So if you can put a front end, late March, it's when it starts. So it's
Could be.
awkward.
Right. Mm-hmm.
No, it's only 2 weeks gap.
Yeah.
Yeah.
Mm-hmm.
Yeah.
But it'll be different every year, though.
But it'll be right.
Okay, we can talk later.
So
Yeah,
we
yeah,
can talk
yeah.
later, but there's creative ways to get around it.
Good. So I have the next few slides are some ones that Matt sent me, talking about sort of this. So the first is just some things from our point of view that make having an exchange program or a more deeply involved exchange program attractive with TAU. One is there are existing exchange programs with electrical engineering and computer engineering. We've had visitors, and the fact that the degree here is taught exclusively in English. I think that option also would be attractive for our students. And of course, having workshops like this as well that we can leverage. So the next, I wanted to just show a couple of things. So this is a list of the type of thing that the Global McCormick is preparing for students to see the type of study abroad opportunities that are available. So you would see a university or where it is, and then what makes sense. Like, do they need to go fall, winter, or just in the fall? How it maps onto the quarters, what language is required, and whether it's an exchange or not. Okay, so this would be the kind of data that we would want to fill.
So with other universities in Israel
Mm-hmm.
already going on?
Yes.
So these exchange agreements, let me see.
Yeah.
Maybe not the engineering,
Okay. Yeah.
Okay.
maybe others.
So
Mhm.
what happens is there's a third party.
Mm-hmm.
So there's a third party. It's not a direct exchange between our universities, but there's somebody else who runs a program, and our students can pay money to this third party provider, like Arcadia University, and then the students basically leave Northwestern. They unenroll from Northwestern for 1 quarter, then they go and enroll in this program. They get those credits. That program sends them over to that university, and then they come back. So it's not a direct exchange between our universities, unlike Tel Aviv. Tel Aviv is a direct exchange, and Koch University, the one on the bottom, is a direct exchange. So that means that our students pay Northwestern tuition, but they show up here to take classes, and every student that comes over here, then there's a certain accounting that you do to determine how many students at Tel Aviv then come to.
At the Hebrew University, they have engineering, but it's only computer engineering.
No, but
right?
it's in Hebrew, it's not in English.
But it's only
Those might
computer.
also be
We-
other departments, right? Those might also
This
be
is
other
this might be other majors too, right? This is
Computer, but only in Hebrew. But
Yeah,
they
yeah.
say none, language requirements.
Mhm.
Of course, the French have language
requirements.
requirements. The Germans a little bit.
Yeah. Is this engineering wide or Northwestern wide?
These are all
Oh, it's engineering.
these are all universities that
Mm-hmm.
there's a much longer list of all the different programs that students could go to. This is a cold list of the engineering relevant
Mhm.
exchange programs, study abroad programs.
Okay.
So I don't know that anyone has ever gone on
Hmm.
this the Hebrew University of Jerusalem as an engineer.
No, they don't have an English program.
Okay.
So something, yeah.
And that's, I mean, it may also be that there's a special English language program that's for foreign students that's not really taking, it's not any sort of exchange program. I'm not certain what that one is.
And the tuition, how much is your tuition?
Oh, you don't want to
It doesn't matter.
It doesn't matter.
Luckily, you want to ask.
No, maybe it will be a good deal for them to come here. It will be cheaper.
No, because the way the exchange program works is that
You still have to pay the Northwestern fee.
Yeah, they still pay Northwestern, but that's yeah. Right.
For undergraduate studies, what you described?
what we're describing is just for undergraduates.
Mm-hmm.
It's 3,000 a year.
Right.
No, not in the international program.
No, I know not international, but
It's 8,000 shekels, so translate
Mhm.
it to.
In the international program, we are $15,000 a year.
Okay. Ah,
A year.
comparable.
Probably less than Northwestern.
Yeah, 30,000, 40,000?
Yeah.
More like 800 now.
No, that's
Mhm.
what tuition
They
for.
complain.
Yeah, I'm sure.
Yeah.
Only
That's a
about,
lot for a state,
only about tuition, no, without
We
dorms.
don't
And
have.
like in Europe.
Good. Yeah.
For Europe, then
Mhm.
for
All right. And so this is mainly for undergrad, but I think graduate is also something that we'd be interested in talking about or exploring if there's.
graduates, we can give all the courses in English.
Okay. All right. So this is this Rosetta Stone that I was referring to earlier. That's they call it an approved course equivalency, or an ACE. I believe this is one that SETA helped prepare for Koch University.
No, this is
No,
IEMS
this is
department.
Oh no, this is the IEMS one. Okay. I'm sorry. I thought. Okay, so this is our IEMS department prepared this, and basically what this tells is, here are courses that are offered at Koch, here are courses that we offer, and the quarters that they're offered in, and then how would they map. So now if a student wants to do a quarter of study abroad, they can just look at this and see, I can do this and satisfy my degree requirements. And
But Northwestern has a junior year abroad, right?
Mhm.
To match with other schools' timetables, that's the easiest thing,
Right.
as opposed to a quarter.
A quarter, right. Mhm.
Well, usually when engineers go abroad, it's not a full year. It's usually going to be just for
Yeah, usually it's one or two
one
quarters.
quarter.
So
And
Randall,
Yeah.
I just looked, tuition only, not room and board, is 46,800. You guys haven't been sending your kids to college lately.
Okay, there you go.
My son to
Interesting.
Northwestern.
You don't pay full freight, though.
Oh, yeah, freight.
How much is tuition, room and board?
Last tuition is $46,000.
46, but with room and board, was it?
That's like 60.
60.
Unbelievable.
But
Yeah.
you know, 50%, what is the statistics of the students get scholarships? They receive 60, yeah?
Yeah,
So
yeah.
they take all the tuition money they receive, and they give back at least 50% of that to the
Right, right.
students.
How many students go abroad?
Because otherwise, we would have no students.
so the number of students who go abroad is typically,
Even for American.
across the engineering school, it's going to be about 8 to 10% in a given year.
But Matt, when you have statistics for engineering students, how much time they spend abroad? And for the whole engineering school, how many students go abroad?
Well, the percentages are like between 8 to 10 or 12% will have an abroad experience. It's not necessarily study abroad. That includes maybe they did an internship, maybe they did a DAAD RISE program in Germany, or maybe there's also these programs where they will go to Africa or Dominican Republic in the summer. So any type of experience
But
abroad.
those are social things, right, to do.
But yeah,
Some are,
but
yeah.
the idea that they're graduating with an engineering degree, but they have left the country
Yeah.
and done some curriculum abroad, that's sort of defined as some sort of abroad experience.
Mhm.
And that's like about 10%. And we're doing, with 8%, we're doing better than the average American engineering school. But compared to Weinberg, the College of Humanities and Social Sciences, or in sciences, they're more like 50% or even 60%. But of course, those are German majors and literature majors.
Majors and, yeah,
People
yeah.
who have a little bit more freedom. They don't take the courses are not sequentially rigorous as for engineering.
Mhm.
Kathleen Stair, who's the assistant chair of the department, her son majored in German and biology, and he went 1 year abroad to Germany.
To
Yeah,
Berlin.
yeah, yeah.
To college
Nice.
with German.
It's really hard for, we're trying to convince them to go, and it's hard to talk them into it sometimes. Even if we see the courses, even if we think it's not so hard to do, but somehow the kids, it's because their culture hasn't developed it amongst them, so they're a bit reserved about
What
it.
are the reasons they
They're
go?
afraid of
Mhm.
losing time.
Afraid of losing time, afraid of, oh, is this course going to be exactly the same as the one I'm taking here? They're very much more concerned about the technicalities, being technical people, I guess.
Well, I should tell you that
Yeah.
I simply tell you that I think if you are studying history or philosophy, going abroad is a great thing.
Yeah.
If you are studying a very sequential course work like engineering, study abroad is often disruptive. So you have to be very
Yeah.
careful because the courses are not structured in the same order, with the same
Right, right,
content.
right.
It becomes very difficult.
Yeah, one
Mhm.
that's why one needs to be careful by when we also advise students, we try to be very careful about that.
So the best thing for students to do is to go abroad only to take humanities classes. You know, come back
And the other thing we're promoting is that like traditionally, as you mentioned, traditionally people say, okay, junior year, freshman, sophomore year, you kind of figure out what you're doing. Junior year, okay, you got your feet on the ground, you can go off and do something. For engineers, we find that it's actually if they can go to the fall of their senior year, or if they're doing a master's program, if they can go during their senior year, or even the fall of their 5th year if they're doing a master's program. The idea is you want to have all of your core courses behind them because it's going to be very hard for a department to sign off and say, yes, this core course that's required of all of our students, they're going to get exactly that same course content at Tel Aviv or somewhere else. So the idea is to push it a little bit later than would be usual for, say, a humanities student, to have students even think about, well, what about the fall of senior year as being a good opportunity for engineers.
You know, for our BSMS students, we require a project, not a thesis, which can be 2 and even 3 quarters. So depends on which professor they pick to work with.
But in fall senior year, they're probably looking for jobs.
Yeah,
That's true too, right.
That's why they have so
The
much
timing's
more
hard,
time.
timing's hard.
they're all looking for jobs.
Yeah.
Most of them already have jobs.
What, in